Yo, what's up, you two learners? And we're here again with covalent bonds, and we're going to talk specifically how to draw diagrams that is used in your curriculum. First of all, we'll talk about chlorine. All right, the formula of chlorine is, well, I think that's too high. Chlorine, and the formula is Cl2. Now, how are you going to represent Cl2 as a diagram? Well, first, again, like I said, you got to draw the valence electron diagram, and you're going to include its valence electrons. Okay? And I'm going to use this chlorine again, because they're the same molecule, so I'll use the same color. They should be the same size, but, you know, my drawing is not perfect. There you go. Now, where is chlorine on the periodic table? Well, it's on the row where if it has 8 electrons, it's going to have noble gas configuration. Right, there's a disclaimer there, but okay. Anyway, so let's take a look at each chlorine atom and how many electrons it has. 1, 2, 3, 4, 5, 6, 7. 7 electrons. So it needs 8 electrons to achieve a noble gas configuration, which means it's energetically lower than its current state right now. So how do we represent the sharing of electrons? Well, these electrons are in pairs, so they're happy, right? Because we know that covalent bonds are represented as pairs, 2 electrons. So if they come in pairs, they're pretty happy. So these electrons here are not really going to undergo sharing of the electrons. But then you have, if you look here, there are valence electrons that are not paired up, right? They are unpaired electrons, and you want to pair them up so that they can share those electrons, so that the new molecule that's formed, the chlorine molecule that's formed, has a lower energy level than the separate chlorine atoms. All right. So what I'll do very simply is to draw a dot line, kind of to represent the sharing of electrons, and of course I'll rearrange them now. Okay, I'll rearrange them, and I'm going to intersect the 2 circles, the shells. I'm going to intersect the 2 shells, and here I have the intersection where they will share the 2 electrons. So these 2 electrons are the electrons you got from here. All right, so I'll just square them as a method of highlighting it to you that they're sharing those 2 electrons here. And on top of that,
who are still on campus, kindly gather in the foyer if you have not been picked up by 4 p.m. Thank you. To all students who are still on campus, kindly gather in the foyer if you have not been picked up by 4 p.m. Thank you.
So these electrons here are represented by this blue highlighted box. You don't actually draw that in. I'm just letting you know by highlighting it that these 2 electrons are actually those lone electrons that are by itself. So they're not happy. And so what we also have to notice that chlorine needs 8 electrons to achieve noble gas configuration. And so we need to draw those 8 electrons in. Oh dear. Okay, it's running out of ink, so I'm throwing that away. So you're going to draw those 8 electrons in, are the remaining electrons. You don't simply just draw it in. You have to know that these electrons here came from these electrons up here. All right, so don't mess that up by just filling in 8 electrons at a time, because you're bound to make some mistakes. So take these electrons that you drawn previously and put it back here. This one here, and that one here, and so on and so on. And that's how you do it. Let's look at another example. Let's look at water. All right, water has an O, and it has 6 valence electrons. All right, and water has 1 valence electrons. And we know the formula for water is H2O, so it has 2 hydrogens. It has 2 hydrogens for every oxygen atom. And when they come together to form a water molecule, these bonds are going to get shared, right? These bonds are going to get shared. And you will represent them like this. Whoops. Let me draw in the intersection of that, like so. Okay, so that's your H. And you're going to draw in the electrons at the intersection of the 2 circles. Great, that's water molecule. Yeah, this is not the only orientation in how you draw it. You can draw it in other orientations like that. All right, it really does not matter. All right, let's move on. Let's talk about methane. Methane is CH4. All right, and how are you going to represent methane now? Well, you have to determine the central atom. Usually it's going to be carbon for the case of all hydrocarbons or chemicals that look like methane. And how many electrons does carbon have? Well, carbon is weird. It undergoes electron shifting called hybridization. You don't have to know what they are, but it undergoes electron shifting where the electrons are now split up into its 4s, and you still have your hydrogens for them, and each of these hydrogens has a lone pair. And so what you're going to do is you're going to try to pair up, because carbon has 4 unpaired electrons and you need to pair them up. So you pair them by connecting the dots like that. All right? You connect the dots like that. Oh, it's almost looking like a bad symbol. Oh well. And you would represent that. Okay? You would represent that like that. Okay? It's quite easy. So that's methane. Let's talk about ammonia now. Ammonia has NH4, NH3, that's the formula. And you need to determine the central atom. So the central atom has to be nitrogen, because that's the bigger one. And nitrogen has 5 valence electrons. And then you're going to draw the H's in with its 1 valence electrons. And then nitrogen has a pair of electrons here, so this pair is happy, this pair is happy. Unpaired, 3 unpaired electrons, so it needs to share them to achieve noble gas or energy stability. And you draw the line again like how I did. And you redraw that a little more nicely. Okay? like that, and that's how you do it. And of course, you have got to check your work to see that each of these atoms in the molecule has a noble gas configuration. Hydrogen has 2 within its boundaries. This hydrogen has 2 within its boundaries. This hydrogen has 2 within its boundaries, and nitrogen has 8 within its boundaries. So all of these atoms in that molecule, ammonia molecule, has noble gas configuration. Finally, hydrogen chloride. All right? Hydrogen chloride has a chlorine and a hydrogen. Now, it doesn't really matter to me about that. Don't mind me about drawing dots and X's and stuff like that. In your exams, they'll tell you how to draw those electrons and how to represent an electron from hydrogen, how to represent an electron from chlorine. But for here now, what's more important is the concept. So again, you have a lone pair, not happy. You have pairs, so these are happy. And you have another lone pair. So draw up those lone pairs, redraw them. Now I'm going to just copy down those valence electrons that have been paired up. Okay. Draw in the hydrogen, and then finish off with the electrons that are covalently bonded. So there you go. A lot of material.